Today we're going to talk a little bit more in depth about lipid in the diet, as well as lipid digestion, absorption, and how lipids can impact our health. So lipids are a diverse group of compounds that share one major characteristic, and that is that they don't dissolve in water. They're composed mainly of carbon and hydrogen. And there are three main types of lipids, including triglycerides, phospholipids, and sterols. Triglycerides are the most common type of lipid found in the body and in foods. Phospholipids and sterols, including cholesterol, are also classified as lipids, although they do have different chemical structures. We can also think about subdividing lipids in our diet into fats, which are solid at room temperature, and into oils, which are liquid at room temperature. Regardless of their structure, they each contribute 9 calories per gram to our diet. Now, we just said there are 3 basic forms of compound lipids, and we're going to talk about each of these today. There are triglycerides, phospholipids, and sterols. And as you can see, they each have differing structures. First, we'll talk about fatty acids and triglycerides. Now, fatty acids are the simplest form of lipid and are found in our bodies and in our foods. Triglycerides are the primary form of fat in our body, and fatty acids make up triglycerides. A fatty acid is basically a long chain of carbons bound together and flanked by hydrogens. At the alpha end of the molecule is an acidic group, so at one end is an acidic group, and at the other end, the omega end, is a methyl group. Now, fats in foods are composed of both saturated and unsaturated fats and fatty acids. Both of a mixture are found in different foods. So whether a fat is saturated or unsaturated is determined by the presence of double bonds, and therefore the saturation of that fatty acid with hydrogen molecules. Saturated fatty acids do not have any of these double bonds, meaning that all of the carbons are saturated with hydrogen atoms. And these saturated fats take on a solid form at room temperature. Unsaturated fatty acids, on the other hand, have at least one double carbon-carbon bond and are usually liquid at room temperature. And now they can either have a cis or a trans bond. Now, a cis bond is found in a fatty acid that is unsaturated and has hydrogens lying on the same side as the carbon-carbon double bond, whereas a trans fatty acid is one where the hydrogens lie on opposite sides of the carbon-carbon double bond. Here you can see examples of several different types of fatty acids. Now, each of these has a methyl group at the alpha end and an acid group at the omega end. The first fatty acid is a saturated fatty acid, and as you can see, there is no carbon-carbon double bond. It is saturated with hydrogens. The second is a monounsaturated fatty acid, meaning that it only has one mono double bond. The third and fourth fatty acids are both polyunsaturated fatty acids and have multiple double bonds. Both of these fatty acids are cis fatty acids because the hydrogens at the double bond are located on the same side of the double bond, either both above or both below visually. Now, we said triglycerides are the most common type of lipid in fats and oils and are composed of a glycerol backbone and 3 fatty acids, which we described earlier. Now, when a glycerol and 3 fatty acids combine in the body, the product is a triglyceride and 3 water molecules. And later in this class, we'll talk more about specific types of fatty acids, including essential fatty acids. Phospholipids are another class of lipids. Now, like triglycerides, these are built on a glycerol backbone, but at least one of the fatty acids is replaced with a compound that contains phosphorus. Phospholipids exist in many areas of the body and are important to the structural integrity of cells, specifically because they are a component of cell membranes. These can be synthesized by a healthy person as needed. Phospholipids have several other functions in addition to being an integral part of cell membranes. They're found in bile acids, which help us to absorb fat from the diet, in lecithins, which is sold as a supplement. However, most healthy bodies can produce all the phospholipids it needs, so it's not considered an essential fatty acid and really isn't needed as a supplement. In addition to making phospholipids, we also get phospholipids readily in our diet from wheat germ, peanuts, egg yolks, soybeans, and organ meats. And we'll talk a little bit more about the important functions of lecithins later in this class. Phospholipids are an emulsifier in foods, and an emulsifier is one that can suspend fat in water by using individual fat droplets and creating a shell where water molecules or other substances are attracted, therefore preventing these from coalescing. One food component commonly used as an emulsifier is lecithin, which is commonly found in egg yolks. Emulsifiers in foods are often used in things like salad dressing and other condiments to keep them from separating into layers of fat and water. And emulsifiers attract fatty acids on the inside while having water attracting heads on the outside. Sterols are the final type of lipid that have a significantly different structure from either triglycerides or phospholipids. They have a waxy appearance and a multi-ring structure and do not have a glycerol backbone. Like other fats, though, they do not easily dissolve in water and are found in animal foods. One example of a sterol is cholesterol, which is found in our own bodies. Cholesterol is an essential component of cell membranes and in the body is produced by the liver. Because of this, it is not necessary that cholesterol be consumed in our diet. However, a typical American diet is high in cholesterol supplied by animal foods. Cholesterol in the body is used to form hormones such as estrogen and testosterone and is the first step in the body producing vitamin D and the precursor to bile salts. It is important to note that cholesterol is only naturally found in animal foods and not plant foods because cholesterol is produced by the liver. So essentially, if a food did not start out with a liver, it most likely does not have cholesterol. Now, the exception for this are processed foods that do have animal products in them. So it is important to look at your foods to make sure you understand where the cholesterol is coming from. Now, lipids can be found in different sources of food groups and can be found really naturally and in processed forms. Overall, fat contributes 9 calories per gram to the diet, more than any other nutrient. In grains, fat is most often found in processed foods such as crackers and dishes with added fats. In vegetables, fat is also usually found as an added product or because it is part of the cooking process, such as the fat needed to fry potatoes to make French fries. There's a popular natural source of fat in the fruit group, which is avocados, but other forms of fat in fruit are rare. Like vegetables and grains, most fat found in fruits is because of processing. In the dairy group, fats are found more readily as a natural ingredient in foods. Whole milk, yogurt made from whole milk, as well as cheeses and sweets like ice cream all have fat. Protein foods also contain fat, either from a natural source, like the fat found on a cut of meat, or the fat in nuts, or as part of the cooking process, such as the fat found in deep-fried foods. As you can see from the previous slide, fat can naturally be found in foods like avocados, meats, whole milk, and nuts, but fat can also be found in foods as a result of processing. At the same time, some fat is obvious, like butter on a slice of toast or fat on a slice of bacon. However, other fats can be harder to find or can be hidden in foods such as crackers, cookies, and other processed foods, or in natural foods like whole milk, where the fat itself isn't necessarily visually obvious, but is present nonetheless. To avoid hidden fats, it's important to learn how to read a nutrition label, as we did earlier in this term, and it's also important to look at the list of ingredients for fats that you may not expect to see in foods. So if a fat is one of the first ingredients on a label, you're probably looking at a high-fat product. If you do choose a food that is higher in fat, controlling portion sizes is an effective way to moderate your fat intake. However, one of the most effective ways to moderate your fat intake is to choose a healthy diet high in fruits, vegetables, whole grains, and lean meats. Fat in food does serve functions, however, and providing flavor, mouthfeel, or texture, and potentially increasing our satiety after eating are some of those functions. Reduced fat foods are now readily available for consumption, and we've discussed reduced fat or low fat foods and how they're labeled in our assessment of a healthy diet. However, just because a food is lower in fat does not mean that it is superior to a food that has a higher fat content. Some foods that are reduced fat have additional added ingredients to compensate for the changes in mouthfeel or loss in flavor. Sugar is a common addition to these foods and can increase the carbohydrate content of foods enough that the new quote-unquote low-fat product may sometimes have the same or higher caloric content compared to the higher fat option. This is one reason that reading a nutrition label is so important to making smart nutrition decisions. Rancidity is the process under which fat decomposes, and a rancid oil is both unpleasant in odor and flavor due to the rancid byproducts. We know that polyunsaturated fats are more susceptible to breakdown as they have a more limited shelf life than more saturated fats. And this occurs as a breakdown of the carbon-carbon bond, double bond, by UV light and or oxygen. To prevent rancidity, there are several options, including hydrogenation, the addition of antioxidants such as vitamin E, or the addition of BHA or BHT, which are synthetic antioxidants to foods. Now, we'll talk a little bit about hydrogenation, which is a process used to stabilize many unsaturated fats through the addition of a hydrogen atom to the carbon-carbon double bond, producing a single carbon-carbon bond with two hydrogens now attached to each atom. However, the fatty acids are not fully hydrogenated to the saturated form because this would make fats too brittle to use in food products. Instead, partial hydrogenation occurs, creating trans fatty acids. So in the process of hydrogenation, unsaturated fatty acids are present in liquid in usually large metal tanks. Hydrogen atoms are then heated and pumped into this oil under pressure, changing the carbon-carbon double bond into a single carbon-carbon bond and producing some trans fatty acids. The partially hydrogenated product is likely to be used in margarine, shortening, or frying. As you can see, cis bonds, the type often seen in unsaturated fatty acids, appear to be kinked. The structure makes these fats more fluid at room temperature and more susceptible to rancidity, whereas in a trans fat, carbons are located on either side of the double bond, more closely resembling a saturated fat. Excessive trans fat intake, though, has been linked to an increased risk for cardiovascular disease, and we now require the labeling of foods containing trans fat and recommend the elimination or at least the significant reduction of the intake of these fatty acids. To limit that intake, it's useful to limit your intake of fried foods, high-fat baked goods, and highly processed foods, and to limit the intake of non-dairy creamers that are not made from natural non-dairy substitutes such as soy or coconut milk.